So today we are learning about handling data consistency in microservice architecture. ठीक है, तो in microservice architecture the data consistency may be complex due to the distributed nature. As you can see, these all are decentralized. They are not connected to each other. They have their own the DB stand for the database, right? So they all have their own databases, right? It has database 1, database 2, database 3, and they all have their different services they are performing, right? Like one is performing stock service, one is performing payment service, one is performing order service. So there are few simpler steps to manage the to manage the data consistency in microservice architecture. We will overlook our, right? The first is eventual consistency. Eventual consistency, right? So in eventual consistency, it is also called, and you have heard about it, like it is also called your, what it is called, event driven architecture. Other name for it is called, you can say, EDA2, right? So in this there are microservice. Instead of enforcing strict transaction, they basically provide ACID. If you know that what is ACID, I will tell you. A means atomicity, C means consistency, C, right, and I means isolation, and D means your durability. These are basically the these are basically, you can use this event to achieve eventual consistency, right? Each service emit event when changes occur, the change occur due to the change in event, right? Or you can say, or an event, when event emits, right, it changes, right? So after that, for an example, there is a payment service. Okay, there is a payment service, and for that payment service, when the payment is processing, right, it is being processed, right? When it is being processed, right, then other services might come, like order service, OS. I will write it as OS, right? Order services, we can listen for this event and update the order status. Like we have, for order services, we will update the event or the order status, update the order status for order service, right? So this is the example of eventual consistency, right? After that, we have sagas, right? The second one we have is sagas, right? A saga is basically, first thing, sequence of local transaction. Local transaction. Right, it is a sequence of local transaction where each service updates its data. Right, it definition is sequence of local transaction where each service updates its data, right, and publishes the event, right, and publish the event when the message is triggered, right, publish the event when the message is triggered. Right, so in this the saga, there are two type of sagas. First is, wait for it, it has two types. First one is choreographic saga, and the second one is orchestrated saga, right? So in this each service know about each other. Right, and in this it controls the sequence of event. It control the sequence of events, right? It controls the sequence of events, like, and it react when the event emitted by others, right? Because each services know about each other. When the service react to the event which is emitted by other services, right, and after that